In this recording, I will talk about the theorem 6 and the 7. The 6 says that if we have an independent event, if you remember, independent says that one event does not influence the other one. The simple example is that flip coin twice. First flip does not influence the second one. They are independent, okay? Or flip a die. It doesn't influence. Or the weather today, it will not, yes, it may be the low probability the weather tomorrow, but they are almost independent. But I should tell you that to say something is independent is very hard. So that needs lots of research. But here the coin and the die examples are very simple, so we can say that they are independent. So one event doesn't influence the other one. Okay. Then the probability that A and the B will happen at the same time is PA multiplied by PB. Okay, so let me give you one example. Say that I flip coin twice. Okay, what is the probability that head will come in both? So what is the probability that it will be head in both flips? Okay, so I know that probability of, so let me give you, how many outcomes do I have? I have 4 outcomes. Yes, it can be head, it can be head and then tail, it can be tail and then tail, and it can be that it can be, the last option is that first one is tail and the second one is head. And what is the probability then? It is 1 by 4. Okay, this is the result. Now let's use the formula. Okay, formula is this one. Okay, let's use it. The first flip, the possibility of head is 1 by 2, because there are 2 outcomes. It will be either head or tail. And the second flip, again the possibility of the head is 1 by 2, because in the second flip as well I have 2 options. It will be either head or tail. So then possibility of head and then head will be just multiply it 1 by 2 and then 1 by 2. Okay, it is 1 by 4. As you can see, they are the same stuff. And this is for the independent events. For independent events, the possibility that A and the B will happen is just multiplication of it. Okay. You see, this is the example here. 60% of the light bulbs are supplied by corporation A, 40% by corporation B. For the corporation A, the quality determined that, quality team, it should be here, 95% of them are of high quality, but 5% is not good to sell. So let's say that this is corporation A. 0.95 is good, 0.05 is bad. Similarly, for corporation B, 80% is good. If I go for corporation B, 0.8 is good, and then 0.2 is bad. What if the probability that a customer buys a light bulb from corporation A and the good, do the same thing for corporation B but bad, and then we need to find all combinations. So the question says that if a customer buys a light bulb from corporation A and then it is good, and then it does the same thing for corporation B but bad, and then we need to find all the combinations here. Let me add a slide for this one to solve it. Okay, now let's solve it. Okay, so we want something to know that possibility that, so it is from corporation A, and then it is also good. And then we want the possibility that it is from corporation B and the bad. And it asks for to all corporation A and then bad, the corporation B and then good. It asks for all the possibilities. And then these are independent events. First, we have to acknowledge that, because that is buying something from corporation A and also the quality of it are two independent events. Okay, buying does not affect the quality. Quality is related to the company itself. It's not related to buying something. Okay, so you can buy the stuff. It may be good or bad, but it is not the buying that affects it. It is the company that affects the quality of it. So these are two independent events. Okay, then it will be that corporation A as an independent problem multiplied by the good. Okay, the possibility from buying corporation A is 0.6, and then to be good is 0.95. And similarly, it will be that corporation B multiplied by the bad, and it will be that 0.4 times 0.2. If you go back here, 0.2 is bad. Similarly, possibility of the corporation A times the possibility it's bad, and it will be that 0.6 times 0.05, and then possibility of the corporation B and then multiplied with the good, and it will be that 0.6 times 0.9. Sorry, I made a mistake. 0.8, yes. These are the, but as I said, these are independent events. So buying the stuff doesn't affect its quality. These are two separate events. The quality is inherent to the company itself. It happens in the company. It may be the machine problem, it may be something, the operator problem. Okay, the quality is that is independent of the company. I mean the buying process. So this is what is the result. But if you add them up, then you will get 1, because we are doing all the possible combinations. And then if you look for the dependent events, the possibility of A and the B, the dependent, if you remember, it was that A affects the B. Whatever happens at A, it affects the B. That's for the dependent events. Let me check. It works. Okay, yes. So then that A and the B will happen at the same time is possibility of A multiplied with that. This is defined as the probability of event B. In other words, event A has already happened. Okay, let me give you one simple example for the P A. Okay, so that, say that we have two baskets, a red basket, and then we have the white basket. And in each basket we have like apple and orange. And here also we have the apple and the orange. Okay, if I am telling you what is the possibility that if I select the fruit P, possibility if I select the fruit and it is apple. Okay, this one is not the full information, because which basket should I select? Should I select from red basket or white basket? I should give you additional information, yes. If I say that the white basket, okay, and then I ask what if the fruit is apple. So you see, I gave you one condition. That condition is A. A is given. What's that? What is the possibility that if I select the fruit and it is apple, given that the basket is the white basket? Okay. I gave you the condition and then I ask you the question. So first I give you the condition. For example, I'm telling you that what is the possibility that it will rain when the month is May? So let me just give you possibility that it will rain given that month is May. Okay, you can see there is one given condition, the additional is asked. Here as well, the A is given and B is asked. So A is like the name or the month or the basket, and then B is the additional thing that is asked. This is for the dependent event probability. So I will solve the next problem in the next recording.